All right, hello, I'm Bella, and I'm going to be talking to you today about a ciliate that has killed a lot of urchins across the globe now. So to start off, I'm going to tell you a little bit about urchins and specifically our genus of interest, Diadema, in general. So today's talk, I'm going to be focusing on two different species of Diadema, Diadema antillarum and Diadema setosum. Antillarum is native to the Western Atlantic and is very prevalent in the Caribbean, whereas setosum is native to the Indo-Pacific and has, as of 2006, invaded into the the Mediterranean Sea. The biggest visual difference between these two species is the bright orange anal cone, or orange circle on the anal cone of Diadema setosum. Otherwise, as you can see, they're very visually similar, and they occupy the same ecological niche in a variety of reef habitats where they're very important herbivorous species, particularly as we've seen a lot of overfishing of herbivorous fish, where they're very important to eat algae. So this is important because in a healthy reef system, they're normally coral dominated. So we have herbivores like urchins or herbivorous fish, which eat back algae and allow coral to grow. But when these urchins or fish are removed, we see a phase shift into an algal-dominated reef, which generally decreases overall biodiversity in these habitats. This is what happened in 2022 in the Caribbean when we saw a massive die-off of Diadema antillarum, which began in the U.S. Virgin Islands, and signs included spine loss, stellate spine arrangement, as you can see here, which is an example of abnormal behavior, and then clearly death when they lose all their spines. I was part of an amazing international team that investigated the cause of this die-off because we wanted to know what the heck was going on. And we found, using molecular methods as well as histopathology, that this ciliate, which is most similar to Philaster apodigitiformis, it was responsible. So using PCR and sequencing as well as microscopy, we found this ciliate burrowed into the tissue of dying and dead urchins, but we didn't really find it in normal urchins. We were able to establish that ciliate in a bacterial culture in the lab, which we've maintained in 2022, at which point we figured that was the causative agent, but we wanted to show that it could kill Diadema antillarum. So we obtained some, infected them in the lab with this culture, which was called FWC2, and as you can see, it did cause some death. These signs are, the term scuticociliatosis was key to describe these signs. In fact, we saw 6 of 10 treatment urchins experience grossly abnormal signs, including behavior and spine loss, and we saw nothing in control urchins. We verified that the ciliate was present in these abnormal urchins using qPCR, and it was virtually absent in control urchins, essentially fulfilling Koch's postulate that this was the causative agent for the die-off in 2022. So this was a win overall. We figured out this was causing a die-off, but this made us wonder, well, is this going to kill anything else? Because we didn't see any other echinoderms in the Caribbean dying, but we didn't have to wait long, because in April 2023, our collaborators at 5 Oceans Environmental Services in Oman were conducting regular environmental surveys in the reefs and observed a large amount of dying Diadema setosum urchins. So those are the ones with the orange anal cone, dying, yes, in the Gulf of Oman. So they were able to collect 8 abnormal urchins for us and send them to us to test for the ciliate using PCR. And here on this map, you can see reports of dying urchins in orange, and in yellow, that's where our 8 urchins were collected. So at the some signs of infection in Oman were pretty similar to the ones we saw in 2022 in Diadema antillarum. A big indicator is loss of tube foot control, which is what urchins usually use to walk around. As a result, they can't attach to vertical surfaces. They use their spines to walk around instead. And we see a lot of this stellate spine arrangement here, which here we have an even better example of stellate spine arrangement which usually results in spine loss and tissue necrosis. And all of this eventually leads to death. Although sick urchins are definitely more susceptible to predaceous fish and invertebrates in the reef. So really, if they could survive, we don't know, because they probably get eaten before they can rebound. So just to give you a little bit of context, Diadema setosum is native to the Indo-Pacific, but is broken up into two clades. So clade A up here is a lot more widely distributed from the east coast of Africa all the way through most of the Pacific, whereas clade B is restricted to a much narrower range in the Red Sea and the Persian Gulf. So these urchins that we got from our collaborators in Oman were all in clade B when we sequenced them, and the urchins I'm about to tell you about were all in clade A. So while we were getting these reports, we were already wondering if other urchins were susceptible to the ciliate. So using our ciliate in culture, I obtained Diadema setosum through the aquarium trade, where they're commercially available, and infected them in the lab. We saw a variety of signs of disease. As you can see, this one doesn't lose a lot of spines initially, and instead has a spine or a stellate spine arrangement. But by day 3, it's lost all its spines because it's dead. So we don't think the ciliates are very picky eaters. While we were getting these urchins from aquarium suppliers, we actually had a number of them come in already infected with the ciliate. But the first was this one, which we remember as SL9. It started dropping its spines in our tanks a few days after arriving. We saw the ciliate via microscopy and dropped spines, and sequencing confirmed that it was the same ciliate that we had seen in the Caribbean. We had urchins, 2 cultures, and a plan. So we repeated the original infection experiments using uninfected Diadema setosum that arrived uninfected. We tested our original FWC2 culture, the new culture from the Diadema setosum that arrived infected, and of course a control. And within a few days, they were both cultures were wreaking havoc. In this experiment, we actually did observe some grossly abnormal signs in control urchins, which we hadn't seen previously. But in general, we saw much greater and more immediate abnormal behavior and signs of infection in both treatment groups. And when we tested tissue types from normal versus abnormal urchins, we saw much higher ribosomal RNA from the ciliate in abnormal urchins. So to summarize what I've told you today, the ciliate, when introduced to Diadema antillarum, causes death. Not only that, but this same ciliate has somehow arrived in Oman and is causing the same effects. And we can confirm that this kills Diadema setosum because we've done it in the lab. So I want to thank everyone who was a part of this team in my lab, and I'll take any questions.